Hi everyone, today we're going to talk about linear equations. I'm fairly certain most of you have seen lines at some point in your educational career. You probably remember that lines have to do with slope. Slope is just the steepness of a line. So I wanted to start with a graph of a line. It contains 2 points A and B, and hopefully you can also see on the graph there is this slope M. Now right now the slope is 0 because I have this flat line that isn't going up or going down, but it's just laying flat horizontally. So what I'm going to do is I'm going to move the line. And notice as I move the point B up, the slope gets bigger and bigger. So you can see it goes from 0, here's 1.5, and it would just continue to get bigger as I raise this point B up because it's getting steeper. As I go, I could get to a vertical, and it's left the page, and then I could come back down and watch as I come down. Now my line from left to right is decreasing, so I get a negative slope. The slope of the line containing the points x1, y1, and x2, y2 is m is equal to y2 minus y1 divided by x2 minus x1. It's important that you put the y's on top, so that's how much it's rising, and then you put the x's on bottom to say that's how much it's moving from left to right. Which point you call x1, y1, and which point you call x2, y2, totally up to you. Let's do a few examples. Let's find the slope of the line containing the points -1, 3, and 2, -4, and then we'll graph. We can say m is equal to, I'm going to use 2, -4 as my second point. So I have -4 minus 3 divided by 2 minus -1. I put the -1 in parentheses because I don't want to lose the sign. I want to pay attention to minus and negative. In the numerator, I have -4 minus 3, that's -7. And the denominator, 2 minus -1, is positive 3, so I have a slope of -7 over 3. To graph, I have -1, 3, so -1, and then down to -3, and then positive 2 with -4. Then we do our best to connect the dots. You can see the slope is negative. I'm moving down from left to right, and we saw that when we did our calculation as well. So let's try it again. This time I have find the slope of the line containing the points 5, 4 and +1, 3 in graph. Our slope, I'm going to use 1, 3 as my second point. I have 3 minus 4 divided by 1 minus 5. 3 minus 4 is -1. 1 minus 5 is -4. A negative over a negative is a positive, so I have a positive slope of 1/4. I expect this line to be increasing from left to right. Let's plot those points. So I have 5, 4, and then I have 1, 3, and then I connect those dots. Let's try another one. This time it says find the slope of the line containing the points 3, -2, and 6, -2. Here's my slope. 6, -2 is going to be my second point. I have -2 minus, I'm putting parentheses around the -2 from my first point, divided by 6 minus 3. -2 minus -2. Well, minus a negative becomes positive. -2 plus 2 is 0 over 3. This slope of 0 says I have a horizontal line. Watch, if I go over and plot 3, -2, put beside it 6, -2, I can see there is no rise to this line, so this line is horizontal and it has a slope of 0. Slope of 0 is not bad. Think about if you ever get on the treadmill, right? So that's my thing, I always think about slope. It asks you how fast do you want to go, how long do you want to go, and what incline you want. And a lot of time the incline I put in is I want a incline of 0. I want to start off a nice walk or a nice run, and then maybe eventually add a little slope to it. But saying I want to start off flat is a good way to start. So we like having a slope of 0. 0 is really good. Think about anytime you want to level something, 0 is what we're looking for. Let's find the slope of a line containing the points 1, -2, and 1, -4. Again, I have my slope. I think you know I'm going to pick 1, -4 as my second point. So I'm going to have -4 minus, I'm going to put parentheses around the -2, and I have 1 minus 1. In the numerator, I'm going to make that negative a positive. -4 plus 2 is -2. In the denominator, 1 minus 1 is 0. This is important. We want to say, what are we going to call that? So there's a couple things we could say. We could say the slope is undefined. You could also write D and E like it does not exist. So when I'm looking, I'm saying rise over run. Well, let's draw this. So if I go 1, -2, and then I do 1, -4, this is rising, right? It's going up, but it doesn't move to the right or to the left. So this is very, very steep. We don't have a number to put on this kind of steepness. This is a vertical line. Let's add in another equation, and this will be the slope-intercept form of a line. We write it as y equals mx plus b, where m is the slope and b is the y-intercept. M serves as the rate of change of the line, so you may sometimes hear a rate of change instead of slope. They mean the same thing. And b is the initial value of the line. But what I mean by initial is it's the value of y when x is equal to 0. So let's look at a few graphs. We're going to start with y equals -2/3 of x plus 5. I want to point out that the slope is -2/3, and then the intercept is 5. So my rate of change of the line is -2/3, and it's going to start at the point 0, 5. So I go to 5, and I put a dot, and then the slope says -2/3, so I'm going to go down 2, and then over 1, 2, 3. There's my second dot. So we're using that slope to say what happens, but the number in the numerator goes first. So it'll go up when it's positive, down when it's negative, and then always to the right. Once you have the two dots, you can connect them. Let's try that again. This time I have y equals 1/5 of x. You can see the slope. It's the coefficient of the x, so I have 1/5. But notice there's no b term. You don't have a number after the 1/5 of x. What does that mean? It means that's a 0. I could put a +0 there, and I have the same equation. So important to think, I always have a y-intercept. I always have a beginning place, but if you don't see a number, go ahead and make it a 0. Now we can graph that. So I go to 0, 0, which is the origin, and then I use the slope. It says go up 1 and go over 1, 2, 3, 4, 5. Connect the dots. And you can see this one's rising, but it's a slow rise. 1/5, it's going up a little and going over a lot. Our next one says y is equal to x. I want to know two things always to start. I want to know what's my slope, what's my intercept. Well, from the last one, hopefully you remember that the intercept's going to be 0. But the slope here, there's no number that you clearly see in front of the x, and when that happens, we know the slope is 1. 1 times x is still x. Because this is a singular number and not a fraction, I'm going to rewrite that as 1/1 just to make it really clear about what's going to happen. So I go to my graph, and I put 0, 0 as my starting point. I go up 1 over 1, there's my second point, and then I connect the dots to get my line. Our next one says y is equal to -3. Now we are trying to look for y equals mx plus b. We have a number this time, so we have an intercept, so our b would be equal to -3. Now when you're looking for the mx, notice that I don't have an x, right? There's no x there, so we're going to say that's 0. So that tells me my slope is equal to 0. So we said, what do we do when the b's not there? We make it 0. What do we do when the x is not there? We say, oh, that must mean that the slope is 0. So zeros are our go-to anytime something is missing. We're going to start at this y-intercept of -3, and then the slope says 0. So I'm not going up, but I'm going over. I'm not going up, I'm going over. Does that make sense? So we're going to the right or to the left, and we're staying in this nice little flat line. So it is important that you start seeing when I have y is equal to a number, you know you're going to get a horizontal line, and I'll write that down for you in another slide. Kind of similar then, here I have x is equal to -1. Now this one's a lot different. We've been talking about lines as y equals mx plus b, and all of a sudden there is no y. That kind of changes everything. Without having a y, I don't have that y-intercept, I don't have the slope to talk about, so I just have to kind of think through like what's going to happen here. Well, what this is saying, it's saying x is -1, and it says x is always -1. So I could have -1, 0, -1, 1, -1, 2, -1, 3. Hopefully you're getting the idea that x will always be -1, y can be whatever it wants to be. I can draw this line. It's supposed to be vertical, doing the best I can, not a good drawer. But you can see this is going up and down. Now what do we want to say? We want to say the slope for a vertical line is undefined or does not exist. So I'm going to write here, slope does not exist. And also, if I look at a y-intercept, this vertical line is not touching the y-axis, so the b, the y-intercept, also does not exist. So both things are missing for this particular line. Vertical lines can be written in the form x equals a. The vertical lines have an undefined slope. Usually they do not have a y-intercept. Horizontal lines can be written in the form y equals b. They have a slope that's equal to 0. Let's find the equation of the line containing the points 3, 7, and 5, -1. We're going to stick to our equation, y equals mx plus b, which is slope-intercept form. Now, when we look at it, we think, well, we have to know two things. We need to know the slope and we need to know the y-intercept. We have an equation for the slope that we've used a few times now. So it's y2 minus y1 over x2 minus x1. So we're going to start with the 5, -1. I have -1 minus 7 over 5 minus 3. In the numerator, -1 minus 7 is -8. In the denominator, 5 minus 3 is 2. My slope is -4. So I have a slope to put in. I have y equals -4x plus b, but I don't have the b. So how am I going to get it? I'm going to use one of these points I have. The points tell me when x is 3, y would be 7. So let's try that. Here's y is 7, -4, my x is 3, and that'll help me solve for the b. I have 7 equals -12 plus b. I move the -12 over, I get 19 is b. So now I have my y-intercept. My line is y equals -4x plus 19. So the best part, I think, of linear equations for our class is to talk about applications and how many times we see lines in the real world. So let's start here with the number of employees at a tech company has been growing linearly. In 2015, the company had 185 employees. The number of employees has increased by 35 people each year. We want to write an equation P for the number of employees X years after 2015. All right. So what have we talked about? We said, well, we always have to have a starting point. When you go through here, in 2015, the company had a starting point of 185 employees. That's our B. And then the number of employees was increasing by 35 people each year. This is our rate of change, which we said is just our slope. So we have both a slope and we have a y-intercept. So we can write P of x is equals to 35 times x plus 185. Now we can use this to do a projection. So let's say, how many employees will the company have in 2025? Start with x is the number of years after 2015. So x is going to be 2025 minus 2015, which is 10. We want to find P of 10. This is 35 times 10 plus 185. This says they'll have 535 employees in 2025. A stock was valued at $65 in 2010. If its value was $195 in 2020, find the rate the value of the stock changed per year. Look at how this is phrased. It says the rate the value changed per year. So the value of the stock goes first. Per is divide, so we'll divide by the years underneath. So we'll put 195 minus 65 over 2020 minus 2010. In the numerator, 195 minus 65 is 130. In the denominator, 2020 minus 2010 says 10. So this says, on average, the value of the stock changed by $13 per year. Now we're going to construct a function v of t for the value of the stock t years after 2010. And then according to that function, we want to find the value of the stock in 2025. So our v of t, we go back and take the 13 that we said the value of the stock changed per year, multiply it by t, and then we add the initial value, which is the value of the stock in 2010. So we're going to add 65. When we're looking at 2025, t is going to be 2025 minus 2010, which is 15. So our v of 15 will be 13 times 15 plus 65. So this says we'll have a value of 260 in the year 2025. A boat was purchased for $7,200 in 2017. The value of the boat decreases $850 per year. When will the boat be worth $2,100? The initial value is the $7,200, so let's call that B, and the boat is decreasing by $8,500 per year, so this is our slope, but when we put it in, we really want to make it negative to show the decrease. Let's turn this into an equation. So our equation will be negative 850x for the number of years plus 7,200, which was our initial starting point, and we want that to be equal to 2,100. To solve, I'm going to subtract 7,200. I have negative 850x is equal to negative 5,100. Divide by negative 850. And this says x equals 6. So this is 6 years. So 6 years means from the initial time that the boat was purchased, which was 2017, 6 years later will be the year 2023. Corey works as an inbound sales agent. He's paid $18 an hour plus 8% commission. Find the total sales Corey needs in order to make $1,200 for a 40-hour work week. So in a 40-hour work week, we know Corey is making $18 an hour, so we're going to do 18 times 40. That's give us our base of where we're starting, which is $720. Okay, so this works as our B. This is what we know as our base. This is the beginning amount that Corey's going to make for working. Plus, he's going to make an additional 8% of any sales. So we're going to write that as an equation. I'm going to call this C for commission and say it's 0.08 times x plus 720. Now what do we want this value of C to be? We would like it to be 1,200, so let's go ahead and put that in. 1,200 is 0.08x plus 720. We're finding out how much Corey needs to sell per week to hit his goal of a $1,200 paycheck. Let's subtract the 720, which is 480. And then we want to divide by 0.08. We have 6,000 is X. A local artist is making bracelets for a large art festival at the end of the year. She currently has 78 bracelets in her inventory and plans to make 12 bracelets a day until she reaches her goal of 1,500 bracelets. How many bracelets will she have in 30 days? Let's label what we have. 78 is the starting amount, so that will be B. And then 12 bracelets a day is how many more she's making, so the 12 works as our slope. So if we want to write it as Y equals 12x plus 78, we can figure out how many bracelets she'll have in 30 days by plugging in 30 for x. So we have Y equals 12 times 30 plus 78. This says in 30 days she'll be up to 438 bracelets. Part B says how many days will it take her to reach half of her goal? Well, her goal is 1,500. Half of that would be 750. So we want to know how many days it's going to take her to get there. So that says 750 is equal to 12x plus 78. We're going to subtract 78. Gives us 672 is 12x. Then divide by 12. And it'll say x is equal to 56 days. So 56 days from where she started, she'll be halfway to her goal.